All right, so let's get started. Hello, everyone. And bardzo witam w mojej prezentacji. Did I get that right? All right, so my name is John. I work as a lead iOS developer at Spotify as my day job. But during the nights and evenings and all the other time I can find, I work on a lot of open source projects. And these days, they're mostly written in Swift because it's a language that I really, really like. Ever since it came out in WWDC a few years back, I jumped on it and I wanted to learn it as quickly as possible. And I was really amazed by how much more productive it made you and how much better code you're writing using it. So today I'm here to talk about how we can make Swift and JSON be a little bit more like friends. You know, to act a little bit more nicely to each other and to work a little bit better together. So why did I pick this topic? Why come here to talk about JSON? Well, JSON is something that we have to deal with pretty much every day as developers, no matter which app that we're working on. And sure, you can use other forms of transportation like protocol buffers or YAML or whatever you might be into. But the fact is that JSON is by far the most common format out there currently, especially if you're talking about modern web services and APIs that you will be calling in your app. And people are using JSON for all other kinds of things as well, like serialization onto disk and config files and you name it. So having a good way to deal with JSON in our app makes a big difference in how productive we can be. In fact, to kind of illustrate how much we use JSON and how kind of core it is to most apps, I have a quote here from Orta, which I really like. It's apps, they're just pretty pictures of JSON. And that might sound a little bit extreme, but if you think about it, what is it that we're doing most of the time when we're building apps? Well, we're calling some API or some server, we're getting some data, and then we're rendering that somehow in our UI. So really, usually our app is a representation of our data, which most of the time, or many times at least, comes in the form of JSON. In fact, where I work at Spotify, we've taken this a step further even, and we've developed a tool that enables us to control pretty much our entire app using JSON. We can send layout configurations and entire view models serialized as JSON and then render them directly on the client. And the good news is that we actually open sourced this tool last week. It's called the Hub Framework, and it's available on GitHub for you to try and download. It's a framework that enables you to build this really declarative, component-driven UIs using JSON or code as your data source. So I'm here today to talk about how to deal with JSON in Swift, not the other way around. So what's the problem? Why am I talking about this topic, and why do I feel like it's a topic that needs some attention? Well, let's start by looking at some of the kind of characteristics of Swift as a language. What makes it special? Well, first of all, I think that, oh, maybe I should use this clicker. Yeah, it's a good idea. I think that Swift is totally awesome. I think that's the primary characteristic of this language. It focuses a lot on safety. It's very much about compile time checks and making sure that we write code which is less prone to errors. It helps us with a lot of the common mistakes that we were doing in languages like Objective-C, such as handling nullability or type checking in a safe way, etc. Because of this, it's also very static. It makes a lot of checks during the compile time rather than during the runtime, which means that a lot of things need to be determined up front, not while the application is running. And that means also that by nature it's very strongly typed. And this is another characteristic which I personally like. I like it when my variables are more predictable, when an integer doesn't all of a sudden turn to a string, that you can make some guarantees about what types your objects are. So those are kind of some of the core characteristics of Swift. So if we look at JSON, on the other hand, we can see that it has some pretty different characteristics. Well, first of all, I personally think that JSON is pretty cool. I like it. It might not be the most sophisticated piece of transport mechanism, but it works. It's great. It's readable. JSON is highly dynamic. It's basically just a string that you can put anything into. You can have arrays and dictionaries mixed together and integers and strings all over the place. And it gives you a lot of flexibility. But it does also mean that it's very loosely typed. It's not a type system. It's not even code. It's just, again, a string or a piece of data that we download from our server. So we can see that by nature, this gives us a little bit of a conflict. The column A and column B, they're not equal. They do not implement equatable. So that gives us a little bit of a challenge when we are dealing with JSON using Swift because of these very different characteristics. Let me show you what I mean by a very simple example. Let's say that we have a user structure in our app that just represents a user. It has a name and an age. Very simple. And we have, a string and an integer as the property. So let's say we wanted to add the capability to initialize the structure using JSON. We would create a JSON file that looks something like this. We would have, again, a name and an age just to match the properties, and they are string and integer respectively. Pretty straightforward. So what do we really need to do in order to take this JSON file and turn it into a user instance? And let's say now that we only want to use the standard library. We only want to write like vanilla Swift and just use a standard library. We would have to write code that looks like this. We would have to implement an initializer, which takes data. And the first thing we need to do is that we need to use the JSON serialization API to turn this binary data into a Swift object. And then we have to do these series of guard statements where we're performing this conditional casting. And in each step, we are checking a variable for a certain type because, again, JSON is super dynamic. It's of any type by default. So we'll need to do this casting to turn it into strongly typed objects. And if something goes wrong during this conditional casting, we will enter the else clause in our guard statement, and there we will throw an error. So we have to do this first for the dictionary, so we get a dictionary that we can work with, and then we have to do it for the name property and the age property, and then decode them respectively. And then at the end of this initializer, we will just call the self init, like the normal initializer of user, and give it the data that we decoded. So there's nothing wrong with writing our code this way. It's, again, super valid. It's a standard library. It works. It's all good. However, as far as I see it, there are a few problems with this code right here. Well, first of all, it's quite lengthy. We are doing a very simple task here. Our model is the simplest model we could think of. It just has two properties, which are both primitives. Imagine doing this in an app which has more complexity. Well, you'll end up with an initializer that is super long because you'll have to do all these steps and check and make sure that things are decoded in a safe way. So it's quite lengthy, and it basically has linear scalability as we scale the complexity of our models. Also, we have a lot of repetition going on here. We can see that we're repeating the same operation pretty much 3 times over. We're doing a guard statement where we're checking the type, and then if the type is a mismatch, then we'll throw an error. And we're doing this 3 times over with different types and different keys. So pretty much the same operation repeated 3 times. We also have a lot of exit conditions here. In fact, this very simple initializer, it can throw in 4 different places. That means that we really have a lot of different code paths that we can go down here depending on how our data looks. And if we want to write a good unit test for this, we would basically have to have 5 different unit test cases that each cover 4 of the error cases and then a final one for the success case. So again, it's a super simple model, but it requires all of this testing and all of these different conditions. But the biggest problem, as I see it with this code, is that it's not reusable. I don't know about you guys, but I really hate repeating myself when it comes to code. I don't like when I have to use the copy and paste commands for a few reasons. Well, first of all, it's general good practice not to duplicate code and spread it all over the place. But especially when we're dealing with Swift, we know that Swift is changing very, very quickly. In fact, you can get an update in Xcode open up your project and all of a sudden it doesn't compile anymore, which makes our lives a bit exciting. You know, you never know what's going to happen. But it also means that code duplication becomes even more of a liability, because if I'm using this JSON serialization API in 100 different places and then it's updated or changed, well, I'm going to have to go through all those 100 places and update all these statements and everything. It's a lot of work. So as I was writing code this way and I was dealing with my JSON just using this normal way, I kind of started to have a there must be a better way moment. I started to feel like, you know, this can't be the best way to deal with JSON in Swift. This cannot be the most optimal or most efficient. So there needs to be a better way to do it. And like I said in the beginning, I work a lot with open source, and I'm a huge fan of especially the Swift open source community and how fast it is growing and how many cool projects there are out there that have these cool new ideas. So whenever I have a problem like that, my first reaction is always to go to GitHub and see what exists. Is there something cool that I can use? Maybe that's just some sample code or a library or someone who has posted some tutorial or something like that that just gives me some ideas and some better tool that I can use. So I went to GitHub and I searched for a good JSON library in Swift. And I don't know if you have done this, but it turns out that there are quite a few of them. Turns out that this is something that a lot of people have attempted to solve. In fact, earlier this week, I made a search for Swift JSON on GitHub, and I found 723 repositories. That is pretty crazy. That is 723 Swift JSON libraries, unique ones, that all do different things. So that is pretty crazy. So what I did was that I started to look through these different projects and sample code and everything that existed out there and try to find something that was I felt was a good match for my project and that kind of looked and had the API that I wanted, had the characteristics that I wanted, and also wasn't too complex and easy to drop in. But I couldn't really find one that I liked. And this is probably the point in this presentation where you either think that I am super picky or super crazy. And maybe I'm a little bit of both, I don't know. But allow me to explain myself what I mean. So the libraries that I found could pretty much be divided into one of three categories. So the first category were libraries or APIs that basically provided a convenience over the standard dictionary. So instead of having to deal with dictionary directly, you got this kind of first-class JSON object that you could just handle in your code. And you got these like .string and .int, so you didn't have to do this conditional casting. And this was really nice, I thought, but it still had the problem of these multiple exit conditions. So I still had to do these manual throws all over the place, and I had to test them in every single model. I also had this repetition still going on. So it wasn't really solving my problem of having these long initializers with a lot of verbosity. So that made me feel like, maybe this is not the best fit. Maybe I feel like I can find something better. The other category that I found of libraries were libraries that kind of took it too far the other direction and just removed all the verbosity completely, and they looked something like this. Now, I know that this comes from kind of the functional programming world, so if you are like a Haskell fan and a Haskell programmer, maybe you can read this like it's plain English, but for me, this is just a bunch of pretty much mumbo jumbo that I don't know what it means. I can just see the word curry here and it makes me think of food. That's about it. So all these operator overloads here just made me very confused, and it didn't make things very clear, at least not for me. So I felt like, maybe not, I don't want to do this. So I moved on. And the third category of libraries that I found were libraries that basically nailed it when it came to the balance between verbosity and convenience. So they had pretty slim initializers, not a lot of repetition going on, but they did require you to have all this mutable state. They basically required you to have all of your properties in your structure or your class to be optionals. And that's because they had this kind of magic functions that would go in and map after your object was created. And for me, this was really not something that I wanted either, because I didn't want to have to unwrap all these optionals every time I was using them. And I also didn't want to introduce a lot of mutable state in my app. I wanted to keep things constant as often as I could. So this was actually a few years ago that this happened. So now there are, of course, a lot more libraries. But a few years ago, this is kind of, or one and a half years ago, this is kind of what it looked like. So it made me start to think, and you can probably imagine what my next thought was. Well, I started thinking, maybe I can make one. You know, maybe I'll give it a shot. You know, I've never made a JSON library before. Maybe it'll be fun weekend project. You know, during the rainy days in Stockholm. We'll see. You know, we'll see what can happen. So I decided to give it a shot. You know, I decided to at least do some experiments to see, could I come up with a nicer way of dealing with JSON and Swift, a way that I wanted to use myself. But before I jumped into a playground and started hacking away, I wanted to set some goals for myself to kind of steer me in the right direction. So the goals I set up was, I wanted code that was easy to write, easy to read, and most importantly, I wanted to keep my model code clean. I didn't want to have these long initializers. I didn't want to spray these operator overloads all over them. I didn't want to have a lot of mutable state. I just wanted things that were simple, easy to understand, easy to test, and easy to read. I wanted it to basically be that if I gave my JSON decoding code to someone else, they could just read it and understand it. So I started attacking this problem. And the first thing that I did was that I took a look at how we did things with a standard library. And I started noticing something that was a bit curious to me. So we were doing these guardlet statements before when we were using only the standard library over and over again with this repetition. And what occurred to me was that there's actually a lot of redundancy here in one of these statements. There's a lot of things that we have to do multiple times. For example, we have to give the key twice. We have to say, first when we're attempting to retrieve this value, we have to say, well, this is the key name. And then if we're throwing, we have to say the key name again. Well, we could, of course, move this to a constant and just have a reference to it, but it still doesn't get rid of the problem that we have to specify twice. And it's not only about, you know, code style or what you prefer, but also it's a little bit of a liability. Because if you, for example, update this code and you forget to update one of the references, then you might end up with some subtle bugs, which can be hard to trace down. So I wanted to have kind of a single source of truth where I only had to specify things once. Also, it felt a bit weird to me that I had to specify this type that I want the string, for example, here in this guard statement. I already know that I want name to be a string because I've already defined that in my structure. This single source of truth already exists somewhere else. It kind of felt a little bit like going back to Objective-C, where you have to declare first what type your variable is and then use the type to initialize it. So a lot of redundancy there as well. You're specifying, in this case, NSURL twice. Felt like I was doing the same thing. But of course, Swift has already solved this problem. It already has this nice syntax where you can just say let URL equals and then a URL, and the compiler will automatically know that, you know what, you're initializing this variable with the URL, so it's obviously a URL. You know, there's no need to specify it twice. And this is very nice. This is a very nice characteristic, hard word, of Swift, which is type inference. And type inference is basically that the compiler, as you probably know, knows more about your code than it did before. It reads it and understands it. It understands more what you mean, so you don't have to give it a lot of explicit instructions. It can kind of derive it itself. So I started thinking, maybe I can use type inference to decode my JSON. Maybe I can leverage the type system and the compiler to do a lot of the heavy lifting for me, so I don't have to do this repetition over and over again. So I started very, very simple. I wrote a very simple decode function, just a global function that would take two arguments, the dictionary that I was decoding and the key that I wanted to decode. And it would also throw, just like my initializer before. And I basically just took this guardlet statement from the initializer and moved it into this function here. So it would have pretty much the same content. It would just check the dictionary for the type, throw if it was a mismatch, otherwise return the value. Now this was a little bit nicer to me because that way I didn't have to have this code in my initializer. I could just call decode, and I had a single implementation of this. I didn't have to scatter these guard statements all over my app. I could just have it in a single place. So where does type inference come in? Well, I didn't just create one of these functions. I actually created a lot of them. Here is another one which returns an int. So it's the exact same function. It has the same name and the same parameters, but it just returns a different type. And it performs the type checking against that type as well. So here we're checking against an integer. So how did this change my initializer? Well, if we go back, we can now see that I can make this single call to self-init in the bottom, and I can perform a single try for that. So I've reduced the number of exit conditions that I have here in this initializer. I just have now a single try on the bottom. And also, I can call this decode function in line when I'm calling the initializer. And this is pretty cool because that way Swift knows that since I'm trying to initialize the name property, it's a string, and the age is an integer, it already knows that. So it dispatches to the right method or the right function. I don't have to manually specify that this is decoding a string or this is decoding an integer. The compiler takes care of that for me and is done statically, so it's really fast. Now, this is a technique which you might be familiar with if you've tried this yourself in Swift maybe, or done it in some other languages. It's something that is a bit new to us as iOS developers because Objective-C didn't have this feature, and it's the feature of overloading. So overloading is basically that you can create functions or methods that have the same signature but different arguments or return types. And overloading is a super nice match with type inference, because since we have type inference, we don't have to specify manually which overload we want to use. The compiler just figures it out. So we can end up with this really nice API where we can just call the same function, but we can get different return types. So I decided by doing these experiments and figuring this out that, you know what, it's using type inference and overloading. That's how I'm going to make Swift and JSON be more like friends. That was my goal. So I started working and evolving this decode function more and more. And that's what ended up being a library called Unbox. And Unbox, it's an open source project. It's been around for about 1.5 years. It was actually written originally for Swift 1, but it has since gone through iterations for Swift 2. And now, earlier this week, I released the 2.0 update, which gives us a new Swift 3 API and all nice Swift 3 features. So when I started with this, I said, I want to have a tagline, a little bit of a one-line description for this library, and I wanted it to be the easy-to-use Swift JSON decoder. I didn't necessarily want to focus on building a lot of features or a lot of complex, capabilities. Rather, I wanted to keep things very simple. Just like this decode function I had earlier, it was pretty dumb, but it was very simple. It did the job, and also it made things a lot nicer. So what did I end up with? How did I continue to evolve this decode function, and what API did Unbox finally get? So if we go back to our user structure that we had earlier and check how would we implement Unbox on this structure, well, we'll conform to Unboxable, which is a protocol that you conform to. So you don't have to subclass a certain superclass or force you to use any specific way of creating your models, because in the apps that I build, and I'm sure in the apps you build, everyone has a different preference of whether to use structures or classes and how to nest them and stuff like that. Then we implement an initializer, which takes an unboxer. So here I took some inspiration from some of the libraries that I found where you had a convenience API on top of dictionary, so you don't have to deal with dictionaries directly and perform the casting and the throwing manually. Instead, you can just call this unboxer and call the unbox method on it, give it the key, and it does all the job for you. So I've achieved the goal here of having my initializer as compact as I can. It doesn't get more compact than one line per property. And I've also removed a lot of the exit conditions and the complexity that we had before. So how does this work? Well, it works pretty much like our decode function that we had earlier. It's just a bunch of overloads of the same function or the same method that just returns different types depending on what you're asking for. And by using, again, type inference, we don't have to do it manually. It's all done by the compiler. So this was my first approach, that I was creating these manual overloads for each type. But that was a bit hard to maintain, and every time we wanted to add a new combination, for example, what if you want to have an array of strings or a dictionary of strings? It required a change in the library. So what I did pretty recently is that I instead changed to a protocol-oriented approach, because I'm a huge fan of protocol-oriented programming, where all these types instead conform to a unbox compatible protocol, and we can just have a single overload for that. And then we can also create overloads that return optionals. And in that way, we can handle optional values that we don't want to fail if they're missing. So we have a lot of flexibility when it comes to values that are required or values that are optional. So if we go back here to our user structure, what do we need to do in order to make, for example, age be optional? Well, the only thing we need to do is that we need to make the property itself optional and remove the try. That's it. So it's very automatic in terms of Swift that, if you are expecting a value, you can use try. Otherwise, you just call the method no try, and it will return an optional instead. So now that you see this initializer, you might be asking, okay, so here's this unboxer. Where does that come from? Like, how do I create that? Well, that's also pretty straightforward. I didn't want to require each model to have to create this object manually and manage its life cycle, etc. Instead, there's a top-level unbox function that you call and give your dictionary or your data. You can also give it an array, etc. And you just call it, and that will create this unboxer under the hood. It will call your initializer, and it will return your model or throw an error. Now you can see here that I'm also using type inference, where the unbox function will return t, where t is an unboxable model. So again, type inference used all over the place in order to have this like one-liner APIs where you don't have to specify things, you just use the compiler. So what about the most fun thing of JSON decoding? All of us that have done some kind of dealing with JSON in our app always have to deal with error somehow. And I don't mean just print error. That's not handling the error, unfortunately. So we have to deal with that somehow. How do we do it? Well, as you can see, there's no error handling code in here. There are no manual throws like we had before. There's no like dealing with any errors of any kind. Instead, we just have this throws here and tries. So how does that work? Well, another problem that I wanted to solve was that there was a lot of fragmentation in error handling. Every model would declare potentially a different error type. If you got an error from JSON serialization, you will get an NS error. So all these handling of the errors became quite complex. I wanted to normalize it. So in Unbox, there's instead just an error enum, which contains all of the cases that can go wrong in JSON decoding. Things like you have an invalid value, or you're missing a value, or you gave us an empty key path, or a dictionary type was mismatched, etc. So that way we can target a single enum instead of having to shatter these error code handling all over the place. All right, so that's kind of just a quick history of how I ended up with this API and how I kind of worked my way there and how I came up with these ways of dealing with this problem. So I don't want to be here today and just give you like the whole API overview and be like the framework salesman or whatever. Instead, what I wanted to do is just give you a quick demo of how Unbox actually works and how we can use it to decode some different JSON structures. So let's head over to the to a playground. There we go. Can you guys read that text? It's okay? Okay, cool. So here we have our user. Whoa, it's very big. Here we have our user structure in the playground here. We have, again, the name and the age. And we can see here that we're loading a local JSON file. I've just named it A out of lack of imagination. And it's this file here. So the same file as from the slides, name and age. And I'm revealing my age here, as you can see, but it's okay because, no problems. All right, so let's go back. So the first thing that we need to do if we want to use Unbox to decode this JSON is that we need to make user conform to unboxable. So let's do that. And that requires us to implement this initializer init with unboxer. And just like in the slides, we will call unbox for each of these properties and decode them. So we're going to say name equals unboxer unbox name, and age equals unboxer unbox age. And we'll add the try keyword in front of them both so that we have the proper error handling. And that's it. That's all the code that we need to write in order to decode this user. And now, when we are actually performing this unboxing, we're loading the data here on line 16. Let's just take that data and turn it into a user instance. So we're going to say let user equals, or we have to give it a type also, and we're going to say try unbox data and give it the data. And that's going to return a user instance. And just to see what this user contains, so verify that we're doing the right thing, we're just going to print it. And we can see here on the playground timeline that we get the user with the name John and age 28. Okay, so that was pretty simple. Let's kick it up a notch. Let's say that we wanted to extend this user model now, and we wanted to add a profession a piece of data to it. So we have in our JSON a string, which is developer. That's what my profession. But in the code, we don't really want to deal with this as a string, because that way we will have to check against string equality everywhere where we're performing this or dealing with this data. It would be much nicer to model it as an enum. So let's do that. Let's create an enum, and let's call it profession, just to match what it was called in the JSON. And let's give it 2 cases just to get started. So the first will be developer. And for me, that's a really fun job. I really love being a developer. One job that I really don't want to ever have, I think, is lawyer. I really don't think that seems like a fun thing to do. So I'm going to take that as the opposite of developer. All right, so what do we need now in order to make Unbox be able to use this enum? Well, the only thing we need to do, we need to mark it as an unboxable enum, just so that it can handle it. We don't need to implement anything. That's all we need to do. And then we just say on our user model, we add a new property. We say profession is a profession type. And then we say profession with a small p equals try unboxer unbox profession. And there we go. That's it. And you can see now that we have, now we get to see also the error handling, which is pretty nice. So we can see here that since we haven't updated the JSON file, it's still pointing to file A. We can see that we get an error because guess what? This was a required property and it's missing from our JSON. So Unbox tells us they have a missing value for the key profession. So you get a nice readable message. It doesn't say NS-JSON serialization couldn't perform operation something, something, something. It just says, you know, what is missing. So we're just going to update now to use JSON file B. And now we're going to get our user instance back. And you can see here we have profession developer here as the data. So that's pretty sweet. All right. So again, these are 2 pretty simple operations to do. We just need to initialize the enum with a raw value of a string. So pretty straightforward. But how about dealing with collections? So here I'm going to do something a bit more complicated. We have here an array of devices that I own. I have my beloved MacBook Pro here, and I'm still running the iPhone 6. I haven't gotten my Jet Black 7 yet. Soon. So I want to model this in code as well. Let's open these up side by side so we can see what's going on. I'm going to go back to the code here, and I'm just going to say open c.json. Just open it here on the side. Whoa. I don't want this big gray bar here. All right, cool. Just so it's easier to work with. So what I'm going to do is that I'm going to create a structure to represent the device. So just like user, it's going to be a struct. I'm just going to call it struct device, and let's also make it unboxable because you know it's a structure that we want to unbox. Let's give it the properties. So we have name and inch size. Those are the 2 properties here. So we're going to say let name, it's a string. And let inch size, it's a double, right? So because it has fractional values there in 4.7, so we can't only use integers here. And same thing again, init with unboxer, name equals, well, we can just copy it from up here because, you know, typing is hard, right? Let's just copy, it's easier. And inch size equals try unboxer dot unbox inch size. All right. Pretty sweet. So that's it. Now we have JSON decoding support for device. So what do we need to do now? Well, we need to add this to our user structure as an array. So I'm going to say let devices is an array of device. And same thing again. I'm just taking the name. So I'm taking devices, and I'm initializing it for the key devices. And that's it. Unbox takes care of everything for me under the hood. I don't have to first unwrap the array, check it that it's an array of dictionaries, then iterate through it, and then check that all the elements are also dictionaries, and blah, 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 blah. I just say unbox, and that's it. So it's all taken care of under the hood. And if I update here to JSON file C, and I get rid of this guy here, we can see in the margin, if we just get this gray little bar out here, we can see that we now also have our devices here in our array as well. So those are just some quick examples of how using type inference is really nice when it comes to decoding JSON, because we can automatically dispatch to the right overload, and we can make our model code a lot cleaner. All right, so unboxing or decoding JSON, it's one operation that we have to do. But what about encoding JSON? That's also boring and hard and error prone, and we have to write these implementations manually where we're iterating through all our properties and putting them in some dictionary. Wouldn't it be nice if we could also, automate that somehow or make that easier? Well, it turns out I have a library for that too. And this library, it's called wrap. So I'm going to import wrap here. And now that I have my user here, I want to take this user and turn it into JSON again. So I'm going to say let user data, and that's going to be data equals try wrap user. And that's going to give me 133 bytes. So to prove to you that this is actually working, I'm going to, because I don't expect you to be able to read binary, let's just make a string out of it. So user data, and the encoding is UTF-8. And we can see here that we have our JSON is back here with all of our properties encoded as we expect it to. We even have automatic decoding of the enum back to its original raw value. So we have all our devices encoded recursively. So that's pretty sweet. You know what we can do to make it even cooler? We can actually go, now we went from JSON to model. We can go then from model to JSON and then back again from JSON to model. You can see I like JSON a lot. I have a lot of fun with this. This is fun for me. So I'm going to do that. So I'm going to say user2 equals unbox user data. And then I'm going to print user2. And we can see we get our user back again. So we have a symmetric code here where we can go back and forth between JSON super easily. And that's pretty nice for being able to serialize things and being able to send things to your server easily. And there's also been a lot of people in the community who have extended this to work with Realm and work with CloudKit and stuff like that. So when you have the type inference capabilities, you can do a lot of fun things. All right, so let's jump back to the slides. So there's a lot of things also in Unbox, a lot of them and Wrap, which have been added by the community. We have actually a lot of contributors now in those projects, which is a lot of fun. And there's things like you can use contextual objects and transformations, and you can use key paths and all fun stuff that you would expect from a JSON library. So finally, to wrap up, haha, funny joke, right? I just wanted to say that if you use type inference, you can have your JSON code be a lot simpler. And by automating tasks like encoding JSON, you can also get rid of a lot of code in your app. You can make it more predictable and less error prone. My goal here wasn't really to sell you on Unbox and Wrap. And my goal isn't that all of you will now, just delete whatever JSON code you have and just use these libraries. It was more to kind of, inspire you to think more about, the capabilities of Swift that you can use in terms of JSON parsing. And whether you choose to use these libraries or some other library or build your own, you saw in the beginning that we just had a decode function. Maybe that works for you. Whatever works for you, really. It's like with all tech decisions, it all comes down to a combination between requirements and personal preference, really. So that's it for me. If you want to check these projects out, they are on my GitHub page. So it's github.com/johnsundell. I also have pinned a link there to the Hub framework, which is a Spotify project to build component-driven UIs. So it's all up there. I'm on Twitter. I'm at @johnsundell. I usually tweet about Swift and development and how things are going at Spotify and stuff like that. So feel free to connect with me there if you want. And thank you very much. Now I'd love to answer some questions. And there's even a Swift book for the reward for the best question. Yes.
Thank you. So looking at the model and the unboxable, it has to conform. It looks like the model matches one-to-one to some specific JSON format.
Right.
But in reality, it often happens that one model had to be serialized from different JSONs,
right.
different versions of APIs at the same time, different format of files.
Yeah.
How would you handle this?
So the good news is that since we have overloads for optional values, you can easily chain optionals as well. You can use the question mark in Swift to say, try to unbox, for example, name. And let's say we change the name later to underscore name or something. You could say unbox name, question mark, name, underscore name. And that way, the first one will be optional, and then the second one will be required. So if the first one fails because it's an old version of the API, and we're now on the new version, then it's just going to use the second one.
But it looks like guessing, right? So it's not, doesn't sound like very reliable. But what if I exactly know that in this case I have to use this format because I have to serialize something from file in different JSON format, and in this case I exactly know that this API requires that format of JSON. I don't want to guess.
Right, okay. So, I mean, you could also, what I've seen some people do in the community is that they use a kind of a wrapper structure for different versions of their API, and then they just unbox that. So it will be a container, basically, which contains just the model. And if their version, they in the beginning of the process, they check what version they have, for example, in the API, and then they switch on that, and then they create these containers based on which version it is. So you could do that, and that way you have your different implementations, they're all separate. So you can very easily delete them once you've completely migrated to a new API or something like that. So yeah, there's all kinds of possibilities. There's also a custom unboxing API, which I didn't show today, which gives you full control over the unboxer and everything in case you need to do more powerful operations. So my general strategy to API design is always what I call scalable API design, which what I mean by that is I start with something that's just a one-liner, and then it scales up to being, very powerful, and you get all the kind of customizability and control that you need. But you should always be able to call the API with just one line. And that's kind of the idea behind these frameworks, is that you can just say unboxer name if that's all that you need. But if you need more fine-grained control, there are APIs for that as well.
Thank you.
Thank you for the demo. It was awesome.
Cool.
I have a similar question, but about the wrapper. So if I want to wrap some field in by a different name in model.
Same philosophy there. So there's a protocol called wrap customizable, where you can specify which key you want to use for which property. So you can say, for the key name, I want to decode as underscore name. So you can do that. You can also use snake case if you prefer instead of camel case. And you can also control the wrapping process completely from just a single property or the entire structure. So again, it's the scalable API design thinking there you saw in the demo. I just called wrap. One line. That's it. That's the simplest use case. But if you want to customize it, you should be able to, right? So I never want it to be too much magic under the hood and you don't know what's going on. It should instead be easy to use, but then if you need to jump in and customize, you should be able to do it.
Thank you.
Hello.
Hey.
Thank you for your presentation. It was really great.
Cool, thanks.
Yeah. And I have one question about this unboxer.
Yeah.
As far as I understand, this library has to be included in each of the module of the project, correct?
Well, yeah, you import it. Like you import it just like a Swift framework.
Yeah, okay.
Yeah.
But doesn't it make that this library and the project model structure become highly coupled?
Well, yeah, yes, it does. Like,
And-
since if you're using an API or a library, then you are introducing a dependency. Like, there's no getting away from that.
Yeah, and what could be your comments? Is it worth to create these dependencies in comparison with the few lines of code that uses the foundation library?
Yeah, so that's kind of what I wanted to get at in the end. Like, again, my plan here wasn't to just like sell you on this framework, but rather just show you how it was implemented or how I arrived at it. So if you, for example, don't want to introduce a dependency, that's fine. I get that. Like, I have the same. I always pick my dependencies very, very carefully. And then again, you can just use like a decode implementation that I showed earlier that you write yourself and you just include it in your project, and that's it, right? So it's really up to you. Like, if you find this, like for me, I find this kind of stuff kind of fun to do, and just do it. Like, but if you don't, if you want to include a library, then it's here. It's
Yeah, but for example, what about you personal? In my perspective, what you would, how you think is it worth to use third-party framework for this kind of operation?
Yeah, I think this is one where it makes sense, because dealing with JSON, it has so many edge cases. You have to do stuff like transformations and decoding collections and stuff like that. And why not just use one implementation that exists and you don't have to rewrite it? If you don't want to. Again, there's nothing wrong with doing that. So yeah, this is one of the cases where I would definitely use a library.
Okay, thank you.
Yeah. Cool. Any more questions? You can also ask me about other stuff if you want. You can ask me about Spotify stuff if you want. Yeah? One more?
How was the party yesterday?
Ah, it was great. Good party. Yeah, it was excellent. All right, guys. Thank you so much for listening. I'll be here in the hall. Feel free to connect with me online. And thank you very much.